Now, so you have the sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. If it's sine minus, everything stays the same, and here there is a minus. So this is how I prefer to write it in a more compact form, okay? And then if you have the cosine alpha plus beta, it's cosine alpha cosine beta. The cosine switches the plus to a minus. That's what you have to remember. Sine alpha sine beta. And if there is a minus here, then there is a plus there. Okay? So the song, right, which everybody knows is, if you write it as sine first, then cosine, it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay? So that's how you can remember the order. Okay, for the tangent, again, it's pretty simple. So you have tangent of A plus beta. It's tangent alpha plus tangent beta. Here you have a switch of the sign. Okay, so it's 1 minus tangent alpha tangent beta. Okay, the way we use this is you have to find the exact value of this. Now remember, when you're given the directions to give your answer in exact form, remember that when you have decimals, you're always rounding, so it's never exact. Exact means roots, fractions, and so on. Okay, so the 75 is not one of our special angles, but we can write it as a combination of two special angles. This will be sine of 45 plus 30. Okay, now, when you do that, then it follows this identity with sine alpha plus beta. So now this is going to be sine, sine, cosine, cosine, sine, right? So sine of the first, cosine of the second, plus, remember, sine preserves the plus and minus. Now it's cosine of the first, sine of the second. So cosine 45, sine 30. Now you have to go and you have to put in their values. We know that sine of 45 is always root 2 over 2. Cosine of 30, because this is the smaller angle, it's going to be root 3 over 2. Plus cosine of 45 is root 2 over 2. And sine of 30, now it's going to be the other one, 1/2. So now, the first term, you have root 6 over 4 plus root 2 over 4. Root 6 plus root 2 all over 4. You have to combine them that way. Yeah, they're always going to be some sort of permutation. All right, so here you have sine of a negative angle, which I like to take out and write as negative sine 7 pi over 12. We know by now that sine of negative theta is negative sine of theta. Now, we're going to have to write the 7 pi over 12 as a combination of our other angles. Remember, the special angles are pi over 3, pi over 4, pi over 6. So in this case, 7 pi over 12 is pi over 3 plus pi over 4. So this is, no, you cannot convert to degrees. You have to do it all in radian. I have to see that work. So this is negative sine pi over 3 plus pi over 4. Okay, so here we have, again, sine, cosine, cosine, sine, right? So it's negative sine of pi over 3, cosine of pi over 4, plus sine, cosine, cosine, sine. So cosine of pi over 3, sine of pi over 4. And again, you have to go in and you have to put in your values. So here we have sine of pi over 3, that's the 60, so it's root 3 over 2. Root 2 over 2. If sine pi over 3 is root 3 over 2, cosine pi over 3 is the other one, and root 2 over 2. So now we have negative root 6 over 4 minus root 2 over 4. So,
The entire thing, so it's like,
oh,
wouldn't it be,
yeah, it's minus minus.
yeah, so it's rad 2 minus rad 6 over 4.
But here, there is a plus.
Oh,
So they're both minus.
can we just go in the beginning and change all the signs, or do we have to do that?
I think that's more work.
It's actually not.
So do we put that as minus root 6 minus root 2 over 4?
Yeah. Okay. Here, you have an alternating current I in amperes. That's the unit for current, right? Amps. In a certain circuit, and it can be found after t seconds using this equation. Okay, now it says rewrite the formula in terms of the sum of two angle measures. So this is I equals 4 sine of, what's 255? It's 210 plus 45 t. So that's all for part A. Use a sum identity to find the exact current after 1 second. So now t is equal to 1.
Why do we
Oh,
use
okay.
210?
So I is,
Because,
well, I want to make 255, so it's 210
Yeah,
plus
no, but
45.
210 isn't like a special.
It is.
yeah,
It's 180 plus 30. So now you have 4 sine of 210 plus 45 times 1. So this is 4 times, in parentheses or brackets, sine of 210, cosine of 45, plus cosine of 210, sine of 45. This is 4 times. Okay, sine of 210, 210 is like 30 degrees, and the sine will be 1 over 2, except 210 is in this quadrant 3, so it's negative 1/2. Cosine of 45 is root 2 over 2, plus cosine in that quadrant is also negative. Sine of 45 is root 2 over 2. So this is 4 times negative root 2 over 2 minus root 6 over, over 4. The 4's cancel. So this is negative root 2 minus root 6.
Wait. Doesn't it just say negative 2 minus root 6 over 4?
Right, but there's a 4 here and it cancels. Now this one, all right, you're given the expansion of the identity. So what you're given is the right side of the identity, and you want to go backwards to this left side, all right? Now, because you have a minus here, that's the minus version. So what you have here is tangent alpha minus tangent beta. So that's going to transform to your tangent alpha minus beta. All right? So here, yeah, so this is going to be tangent of 78 minus 18, tangent 60. All right? Now 60 faces root 3 over 2 over 1/2, right? So this is going to be root 3. What's tangent of 60?
Yeah, tangent 60 is just root 3 over 2.
Over 1/2.
Why?
It's sine over cosine.
it's not sine.
60 degrees, right? This is root 3 over 2, and this is 1/2. Tangent is y over x, root 3 over 2 over 1/2. All right?
I thought, isn't it root 3, 1, and 2?
That's if you have a regular triangle. In the unit circle, your hypotenuse is 1, so you have to account for this.
I still don't know why.
Yeah.
this one here is an expansion of one of our other ones. So look at what you have here.
What about the second part of what
We're
about
done.
1 plus over 1 plus 10? Where the bottom is 1?
1/2. It's
There's-
3 over 2 over 1/2.
There's an equation you have to follow,
Oh,
and we're
so,
trying to
okay.
find tangent alpha and beta.
Okay.
Okay. That whole thing, the top and the bottom, that whole fraction equals tangent alpha minus beta. Now what we have here is cosine of a number, cosine of another number, plus sine of that first number, alpha, sine of the second number, beta, right? So what do we have here? We have cosine alpha, cosine beta. All right, so what trig identity is that one?
The cosine one,
Close your laptop.
the negative, isn't the negative?
Not
Close it all together. But we'll
The
turn this
difference
down. I'd rather
identity.
you be with us now, okay?
It's the difference identity for the cosine.
So this is, right, this is the same as cosine alpha minus beta, right? So this is cosine of your first angle minus your second angle. Okay? Now we have to simplify this one. Cosine, what's that going to be? You have 21 pi over 4 minus 5, so it's how much? 16 pi over 24, which is how much? You do reduce it. This is cosine 2 pi over 3. Now, if you have a pi over 3 angle, that's like your 60 degrees. It faces the large side, so the cosine is 1/2. Now, 2 pi over 3 happens to be in quadrant number 2, where the cosine is negative, so there is a negative in front. Okay? Now, stay with me on this one. If it's a unit circle question, I'm going to defer it to later.
Yeah, I just don't understand what's the difference between the last one and this one and why you use the unit circle on the last
It's another unit circle.
I'm using the unit circle on this one too. Our JR, you and I can talk about this later, okay? We'll talk about it later. Okay, here what you have is this. You have the cosine of some stuff. What's the stuff? You have something plus something else. So it's like you have the cosine of alpha plus beta. All right? So you're going to have to put in the identity. It's going to be cosine, cosine, sine, sine. So this is going to be cosine of the first one, alpha. So it's arc sine root 3 over 2.
Do we write sine -1 root 3 over 2?
Sure. So cosine of the first one, cosine of the second one. Minus, right? Sine of the first, sine of the second. So sine of arc sine root 3 over 2, sine arc cosine x. Yeah, so now look, I'm going to try to color code this. The ones that have sine and arc sine and so on will cancel out. So cosine and arc cosine of x will just give you x. Sine and arc sine of root 3 over 2 will just give you root 3 over 2. Now, I'm going to do this part in green. We have cosine of arc sine of root 3 over 2. What I do is I start from the inside and I draw a triangle, theta. You don't even, this is actually the unit circle, so let's do it with the unit circle. What angle gives you sine of sine root 3 over 2? It's the 60. Now what's the cosine of it? 1/2. So this is 1/2. Okay? Now, this one. Okay? Sine arc cosine of x. We're going to draw a triangle for this one. Starting from the inside, okay? We have an angle theta, the cosine of which is x. Adjacent over hypotenuse is x. All right? So this side is 1 minus x squared in the square root. Now we need the sine. What sine of theta?
Root 1 minus x squared over 1.
Right. All right? So this is the square root of 1 minus x squared. So now putting it all together, I have on this side I have 1/2 times x minus root 3 over 2 times the square root of 1 minus x squared. You combine the denominators, all over 2, and I have x minus root 3 times root 1 minus x squared. You distribute the 3 inside the root, so it's the square root of 3 minus 3x squared. And that's your answer. Okay?
I have a question.
Over 2. Yeah.
Why is it over 2 if the x isn't over 2?
It's 1/2 times x, which is x over 2. All right, let's do one more. We're going to expand this. This is sine of alpha minus beta. So it's sine, cosine, cosine, sine. So we have sine, arc tangent of x, sine, arc cosine of x, of half, minus, sorry, it's sine, cosine. Minus cosine of the first, sine of the second. Now the only thing we can simplify right off the bat here is this one, which gives you 1/2. Okay? The first one needs a triangle. I draw a triangle, the tangent of which is x, right? So opposite over adjacent is x. The hypotenuse is x squared plus 1 in the square root. So the sine of theta is x over the square root of x squared plus 1, which is x times x squared plus 1 over x squared plus 1. Okay, I rationalized the root. No. 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 You guys are giving me a heart attack here, the two of you. No.
I don't even know.
You can't because they're both
That because it's a plus, it stays as a unit. Okay? That's fine. I'm just kidding. So this is that. Okay. Here, this one is the same triangle, right? Because you have a triangle, the tangent of which is x. Now you want the cosine. What's the cosine of theta?
cosine is 1 over
The square root
squared
plus 1. So it's the square root over x squared plus 1. Now, the last one, I'll do it in this color. Okay. If the cosine of an angle is 1/2, what's the sine? Root 3 over 2. Now, let's put them all together, and I get x times the square root over x squared plus 1 times 1/2 minus the square root over x squared plus 1 times 1/2 times root 3 over 2. Do you see how they both have the same denominator?
Yeah.
You combine them over the same denominator. So what do I have on top? I have x times x squared plus 1 minus root 3 x squared plus 1.
Wouldn't that just be
And there's like, you could do so much.
Plus 3.
Minus
wouldn't
3.
it be root 3x squared plus 3?
Right. So this is, I think that's the cleanest way of writing it. is if we just combine that and write 3x squared plus 3.
Is it okay if I put the bottom as 2x squared plus 2?
Sure.
You just leave it like that?
Yeah. All right, now, do you guys remember this identity?
Yeah.
Okay, this says to prove the identity. Now, if we're verifying identities, that means we're just going to work on one side. Okay, so what's another way using sum or difference to write like -3? How do you get -3?
1 minus
Three times negative
Simpler, using plus or minus. Simpler, you could just do 0 minus 3, right? So we're going to rewrite the cosine of negative theta as cosine of 0 minus theta. Because 0 minus theta, that's negative theta, right?
Yeah.
Okay. So now you have difference of cosines. So we're going to do cosine, cosine, sine, sine, switching the negative to plus. So cosine 0, cosine theta, plus sine 0, sine theta. Now, what's cosine of 0?
Oh, shoot. I'm so sorry.
1.
Bruh.
What's sine of 0?
Undefined? Oh, just kidding. I was thinking
0.
Yeah.
So what do we have here? 1 times cosine theta is cosine theta plus 0. Cosine theta equals cosine theta. So that's how you prove that identity. Sine theta, it's 0 times that, it's just 0. The whole thing becomes 0. All right. Okay, we have to do this. Come on. All right, this is a similar one. We're going to do cosine, cosine, sine, sine. So, cosine theta, cosine pi over 2, minus sine theta, sine pi over 2. My alignment went off there. I hate that. Okay. What's cosine pi over 2? You were right for 0. What's sine of pi over 2? 1.
1.
Oh, look, this should be a plus.
Yeah, because it's a negative.
Yeah. So this is a 1. That means sine theta equals sine theta, and there. Okay? Now this one. We're going to solve this. This is an equation like section 5.3, but you're going to use the identities from section 5.4. So here we have sum and difference. Here we have sum and difference. Let's go. For the first one, it's going to be cosine, cosine, sine, sine. Cosine x, cosine pi, minus sine x, sine pi, minus, now we're going to do this one, sine, cosine, cosine, sine. Sine, cosine, minus cosine, sine. What? Come on, Sarah.
Yes.
You're breaking the momentum here.
Momentum.
We got this.
We got this. We're doing this. Okay, so now we have cosine x, cosine pi, minus sine x, sine pi, minus sine x, cosine pi, plus cosine x, sine pi. Catch my mistakes if there are any, please. Now, what's cosine of pi? Don't you dare say 0. What's cosine of pi?
0.
Close, close, close.
Negative 1.
-1.
What? Wait.
What's sine of pi?
0.
What's cosine of pi? What's sine of pi?
0.
So what do we got here? Negative cosine x. Negative here. Plus sine of x is equal to 0.
Wait, what about the two negative? How do you get two negative ones?
Negative cosine of x.
Oh.
Negative positive
I get
sine of
it.
x.
I have no idea.
Okay?
Okay. That's it?
It's
Wait, why
zero.
So look at because we're solving this. This is we have to solve. So look at the quick way that we can do this. This tells you if you just add cosine x to the other side, that sine x is equal to cosine x, right? What's the angle where sine and cosine are the same? 45 degrees.
So x equals pi.
So x equals pi over 4
Plus 2 pi n.
and 5 pi over 4. All right? Pi over 4 and 5 pi over 4. Because that's the only case where, only in those two quadrants, is sine and cosine the same, including the plus or minus. In the other two quadrants, one is positive, one is negative. So that's the answer. Now this is going to be due Monday. You also have a quiz on Monday.
5.1 to 5.3, right?